Okay, in this video I'm going to go over how to do the Lathe CAM for this Plumb Bob. Some things to note: we have a tapped hole on each end, which means that we're going to need to flip the part in the lathe to tap the other side. Looking at this shape here, this is a cylindrical shape, so this could be held in the 3-jaw chuck on the second setup, and so it's recommended that we machine all of this first, do the cutoff, and then flip the part, hold this side, and then drill and tap on the opposite side. One concern with flipping the part is ensuring that this hole is aligned or coaxial with this hole. And so one way to ensure that is when you do this drilling operation on the first setup, you could drill all the way through. One thing you need to make sure is that your drill bit is long enough to do that. I am going to demonstrate that when I do the setup, but then when going to the actual lathe, you would need to measure the length of the drill bit to make sure that it is sticking out longer than the length of the part plus the depth that you're cutting. So notice this is 1.358 inches. So if it's 1.6 inches or something like that, we should be fine. And if it's not, we would need to pull the drill bit out in the collet that it's held in so that it's long enough. So going through on the setup, we go to the cam tab, go to setup. First thing is we want to tell inventor that we're using a lathe, and then what I'm going to do is flip the Z-axis and go to the stock. I am not sure of the stock size. Inventor chose 1.5 inch. That's a common size, so we'll just stick with that. We could probably find something a little bit smaller, but we don't always have the incremental size of stock that we would like. So there is a fair bit of waste because the stock is a little bit bigger than the diameter of the part. One thing I do want to do is go offset from the front so that the Z-axis or the XY plane is right at the surface of the part. Basically, we would face the part, set that as Z0, and then start the machining. So now that we have the setup done, I'm going to go to drill, select what I want to drill, go to the tool. On the lathe tools, this is a 1032 hole, so we need a drill that will eventually be tapped at 1032, which is this drill bit, 0.159. I'm going to go select. Notice by default it sets the bottom depth at the bottom of the hole. What we're going to do is, instead of going to the whole bottom, I'm just going to go selection and select here, and then maybe we can go an additional 1/8 of an inch further to make sure that we've broken through. Notice that we need to make sure that the drill bit is that long to be able to get through that. Now, we want to not just do a standard drill. I recommend that we do a full retract deep drilling, and then so it will go in almost 40 thousandths, and then clear the chips, go in again, the additional 39 thousandths, and keep doing that until it's all the way through. We'll keep the default settings for the tool at 12,000 RPM, and then hit OK. I'm sorry, 1200 RPM, not 12,000 RPM. Now that we have this drilled, we're going to go to drill again, but this time we're going to select the tap. So on the Tormach lathe tools, we'll select the tap, 1032, which is here, the 1032 tap. Select that. The geometry is this. The height will just go to the bottom of the hole here. We're not tapping all the way through. And then the cycle, I recommend that we do tapping with chip breaking, and so it goes in, by the default is 47 thousandths, so it goes in 47 thousandths, comes out, goes in, comes out, until it's made it all the way through, or into the bottom of the hole. I have, when I set up the tools, I set up the speeds, and so the spindle speed is reasonable at 500 RPM. Realize that the machine has to reverse direction when the tap is coming out of the part. And so the Z speed, or the Z feed rate, must be clocked with the rotational speed to get that tap correct. So now that we're done with this, basically we're just doing the standard contour. So I'm going to do profile roughing. Going to use, should be able to use tool 1 here, just the standard profiling tool. 1 or 2 would be fine. I'm going to select this tool. The speeds, definitely going to bring the speed down. And I am also going to change the depth of cut, maybe to 20 to 25 thousandths. And I'm just going to go to the back of the part. Model back is, so it's going to go here. And there should be a little bit of stock to leave. And it looks like we're okay there. So I'm going to hit OK. See what that looks like. Looks reasonable. Notice that we're not able to get this, and so what we need to do is see if we can do that with the other tool. So on the other tool, we're going to change this to tool 2 and select, go OK. And now with tool 2, since it's a sharper tool, we can actually get all of that shape on the back. Now that we have this, we should be able to do a finish pass. So I'm going to right click, create drive drop operation, turning, profile finishing. Here I would basically change the heading feed rate to 5 thousandths or smaller to get a nice finished surface. And it's always nice to do a spring pass. Now we have that complete. Then the last thing we're going to do is just do an end cutoff. And so we're basically going to part with the parting tool. So selecting the lathe tools on the parting. I think it's this tool here, select. It already knows we're going to the back of the part. I'm just going to change this to 2000 RPM on the maximum spindle speed, hitting OK, and we part that off. Then all we would need to do for the second setup is the tapping. And so I am going to create a new setup. Now we're going to have the part like this, and so all we need to do is go to the stock, go to offset from the front, go OK, and then all we need to do is the tapping. And so I'm just going to hit the drill, tap here. The tool is the tap. It looks like that's what it already has. The geometry, the depth is the whole bottom, and then the cycle we're going to just do tapping with chip breaking. Hit OK, and we tap that other side. The reason why we didn't need to drill is because we drilled all the way through on the first side. And I would recommend doing that if I were making that part, just to ensure that the hole is, these two holes are coaxial, just making them one. One issue when flipping the part and grabbing this side in the 3-jock chuck is this side you're not necessarily going to have zero run out. It's going to be wobbling a little bit, and so the hole here would not be coaxial with this hole here unless you drilled all the way through in the first setup. And that's it.